All right, we're going to start taking a look now at our Chapter 9 Stoichiometry. And this is pretty difficult chapter to get into. And I want to emphasize that you should be keeping up every day, practicing the assignments every day, and if even possible, making your way into school because this content is very, very difficult to try to learn online. And so I want to just encourage you to try to come to school as much as possible so that way we can just kind of stay together on this. If you get behind in this material, it's very difficult. Please ask questions as soon as you have any. So the first thing I want to do is take you through the double roadmap. And so hopefully you've gone through the learning agenda up to this point, so you know a little bit more about stoichiometry. I want to take you through the roadmap that you're going to use in order to make it through each problem type. So the first area where you may start is you may start at volume, and then you would need to convert to mass. Not always going to start at volume, but there is a chance. You may start at particles. Right? Those are atoms, ions, molecules, or formula units. The first thing that you want to do, and this is your step one, is you're going to convert to moles. Okay, so step one is going to be convert to moles. That should sound very familiar. And these steps are going to be the same as they were before. So after we convert to moles, we're going to go through the mole ratio. And that mole ratio is going to be a little different than it was before, as it's going to come from the balanced chemical equation. So you may end up having to balance an equation in order to find that middle step. That will take you out into moles, to which we could then go to mass and then volume, or it might take you to particles, just depending on what the question is asking. Most of the time we live in mass. We may live in volume as well. But again, we're for the most part, living in particles. So one thing to keep in mind is that there's some conversions that we're going to be using to get through this. So to go from density to mass, we're going to need, from volume to mass, we're going to need the density. And so that would have to be given to you in the problem. To go from mass to moles, we're going to need the molar mass from the periodic table. From particles to moles, we would need Avogadro's number. And then those are going to be the same on the other side. We're going to repeat density here. We're going to repeat molar mass here, and we're going to repeat Avogadro's number for particles. So keep those things in mind as we go back through the steps. I apologize for that. As we go back through the steps, so step one is going to be always convert to moles. So wherever you're starting, whether it be mass or particles or volume, you want to do what you need to do to get to moles. Step two in our math is going to be that mole ratio step. And then our final step three is going to be our multiply by either the molar mass or our Avogadro's number, depending on what it is that we want our final answer to be in. So basically for these stoichiometry related problems, we're going to be looking at a balanced chemical equation, figuring out what we need in order to make the conversion to where it is we want to go. So I have a sample problem here, and you might see a problem that looks like this. This would read calcium nitrate plus sodium carbonate reacts to form sodium nitrate and calcium carbonate. Okay, so as we work through, the first thing that we need to do is balance our equation. I'm not going to spend a lot of time balancing. It's something that we should be skilled at by now. But there's one Ca on the left, there's one Ca on the right, there's two NO3 groups on the left and only one NO3 group on the right. So I'm going to put my 2 in front of the NaNO3 on the product side. And then that would give me 2 sodiums, and I have 2 sodiums on the left. So we are now completely balanced. So you're going to see something like this. 15.5 grams of calcium nitrate is reacted with excess sodium carbonate. So that means that we have more sodium carbonate than what we actually need. the question would then say how many grams of sodium nitrate and calcium carbonate would be produced. And so you'll notice that in my balanced chemical equation, I put question marks under the things we're going to look for. One of the most challenging parts of stoichiometry is kind of keeping track of where we're going and what it is that we're trying to find, because there's just so much information. So we're going to move through our steps. Our given is in grams, and so we're going to move through our steps in order to find the moles, and then we're going to use the mole ratio, and I'll show you where that mole ratio is going to be coming from now, and then we'll multiply by our final unit. So let's go ahead and move through step one, and we're going to convert 15.5 grams of calcium nitrate, and we are going to go to the NaNO3 first. So let's go ahead and move through. We've got our 15.5 grams of CaNO3 2. If you were not in class, or maybe you missed it, you have to keep track of units and labels through all of your work for these types of problems. I will be evaluating that. So if you're not keeping track of units and labels, you will miss points. Okay, so I just want you to keep that in mind. The first thing that we need to do in order to convert to moles is we need to cancel out with molar mass. So I need the molar mass of CaNO3 2. We worked on this a little bit yesterday, so I'm not going to recalculate that here, but 164.10 is the molar mass from the periodic table for CaNO3 2, and that's going to be 1 mole then on the other side. So you'll see now that my units cancel. Again, I'm going to be looking for you to come in here and cancel the units. So what we just did was step number 1, convert to moles. Next, we're going to do step 2. And step 2 is that mole ratio step. Now, before, our mole ratio came from inside the formula. But now we're working from one type of chemical compound to another. So we're going from CaNO3 2 and we're trying to get to NaNO3. So what we actually need to do is we need to look for the coefficients in front of the balanced chemical equation. Okay, we want those coefficients in front of the balanced chemical equation. So my coefficient for the CaNO3 2 is going to be 1. And that's going to go on the bottom because we want to cancel the unit of the CaNO3 2. So those are now canceled. And now I can put the mole of the compound that I want to have up on top. So you'll notice that my units line up to where I'm no longer in CaNO3 2. I am now in NaNO3. I can now do my step 3, which is going to be multiply by the units that I would like to be in. So I need to be in grams, so that means I want to cancel moles. So mole will go on the bottom. And I want to be in grams, so I need to go to that periodic table, find the molar mass. And I can now cancel those out. Again, the 100.09 just comes from adding up 1 sodium, 1 nitrogen, and 3 oxygen. We want to go back and verify our number of significant figures. So here is 3 sig figs. I was hoping to get a different color. Okay, so 3 sig figs in our given, so we need to make sure that we multiply our answer. Round our answer to 3 significant figures. Make sure you're putting parentheses around the denominator here. And our answer rounded to 3 significant figures, 9.45 grams of NaNO3. And so during this reaction with excess Na2CO3, we would produce 9.45 grams of NaNO3. So what we did was, this was the path that we took for our roadmap here. So we went mass to moles, through the mole ratio to moles, and then up to mass once again. And so that's the direction that we're going to be going on quite a few of these. We may start at volume, which we would need to cancel units with density, and we'll probably do that more tomorrow. But we're not done. This problem isn't quite over yet. As we take a look at our work, we're asked to also calculate what we would get for the CaCO3. So we're going to go ahead and do that. Our given is going to be the same. So 15.5 grams of the calcium nitrate over 1. And our step 1, still also the same. We want to get ourselves to moles. So that means we're going to have 1 mole of calcium nitrate on the top. The same mass on the bottom, because we're still in calcium nitrate. So we need to just cancel out the same units with the grams, with the mass of calcium nitrate. Again, I have to see those units being canceled. Step 2, now we have that mole ratio. So as we go back up and look at our balanced chemical equation, the coefficient in front of the calcium nitrate is still a 1, but now we're comparing it to the calcium carbonate, which is also a 1. So let's go back down into our equation and let's go ahead and apply those coefficients. So 1 mole of the CaNO3, and now 1 mole of the calcium carbonate, CaCO3. And so our units cancel. And so now we're out of moles of calcium nitrate and into moles of calcium carbonate. And now we can just do, again, that same final step, because we're converting to mass. We're trying to get to grams. So we want to cancel the mole of the calcium carbonate. And then you would need that mass from the periodic table of calcium carbonate, which I realize now that I accidentally switched them. So this is 1 mole. I'm sorry, 1 mole. This is the 100.09 grams of calcium carbonate. Let's cancel these units so that we can see that they cancel. And then this would get you the 9.45 grams of CaCO3 as our final answer for that one. And then we need to go back up here and adjust this first question. So if you caught that as we were going, great job for paying attention here. I always am emphasizing to my students that are in the classroom that you don't just want to copy down what I'm saying. You want to be entering things in your calculator. You want to be looking to make sure that things are done properly, and that should be the same for at home. So the mass of NaNO3 from the periodic table is actually 85.00 grams, which when calculated out would be 16.1 grams of NaNO3 that is produced. So again, I apologize for that, but you can always pause the video as you're doing calculations as well. Do make sure that you don't forget the coefficient here when you multiply across the top for that first one. A lot of times students forget to put the 2 in there just because it kind of blends in with everything else. So please make sure that you're careful on that. And then as we look down here at the bottom, we end up with the 9.45. So what this is actually telling us is that if we were to perform the reaction of calcium nitrate plus sodium carbonate, we should expect to get these masses for our products. And so one of the labs that we're actually going to run is, hey, let's calculate mathematically what we should expect from this reaction, and then we're going to go ahead and run the reaction and see how close we get. And that's going to be a theoretical percentage, percent error, where did my masses go type of lab. and I look forward to that. So I have that slated for the end of next week before spring break. If anybody is interested in coming in for that, just check the week at a glance at the beginning of next week for what day that lab is going to be. At the bottom of the learning agenda, you're going to find a number of practice problems. These problems are very challenging. I will be releasing an answer key, but I do expect quite a few questions as we move through this week on these types of problems. Please make your questions specific, and you can always send me an image of your work, and I can take a look at where you're at for that. Okay? Well, thank you very much, and please let me know if you have any questions.